this video, we want to continue with ways of constructing our sample sizes. We've already discussed the fundamental counting rule, where we just multiply the possibilities out because they're independent of each other. We've discussed the permutations, where we're selecting 4 items from the same group, but there's an order to it. Now what we're going to look at is combinations. Combinations is where we select some of the items from a group, but order does not matter. So we don't care which order they are selected in. So the number of R objects chosen from a group of N objects, this is our sample size, this is how many we're selecting, is NCR. N choose R. The formula for this is going to look similar to the permutation, except in this case we're going to have an R factorial times an N minus R factorial on the denominator. So it does change us a little bit. When we calculate these, you will notice that there are fewer combinations than there are permutations. Because 4 people selected, if we don't care which order it's in, they can only be selected one way. But 4 people being selected in order, it changes how many we can have. There's more ways that we can have 4 people selected in order. So let's look at an example. How many different simple random samples of size 4 can be obtained from a population whose size is 20? So this means we have N being 20, and we're going to select 4. So we're going to have 20 choose 4. That is 20 factorial over 4 factorial times 20 minus 4 factorial. This is 20 factorial over 4 factorial times 16 factorial. When I write this out, my numerator is 20, 19, 18, 17, 16, and I'm going to go all the way down to 1, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Over, my denominator is 4 factorial, 4, 3, 2, 1, times 16 factorial, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. I can simplify this. You'll notice that 16 and below is the same thing as this 16 and below. So those are going to divide out, which leaves me with 20 times 19 times 18 times 17 divided by 4 times 3 times 2 times 1. Whenever I multiply and divide this, I get that there are 4,845 different ways 4 items can be selected from 20 items. And so we notice that in this particular case, we actually have fewer items because we're looking at combinations and not permutations. So again, there are 4,845 different simple random samples of size 4 from a population whose size is 20. Now I just want to look at something quickly so that I can illustrate a little bit more about the permutations versus the combinations. So let's say I pick 3 students. I pick Joe, I pick Lisa, and I pick Brian. Okay? If order does not matter, it doesn't matter if I pick Lisa, Joe, Brian, or if I pick Joe, Brian, Lisa. I've still picked the same the same 3 students. I could pick Lisa, Brian, Joe. I could pick Brian, Joe, Lisa, or Brian, Lisa, Joe. So again, it doesn't really matter which way I pick them. I'm still picking the same 3 people. Say that I pick them for a group. I'm still picking the exact same 3 people. Now, if it mattered, president, vice president, secretary. Here, Brian would be president, Lisa would be vice president, Joe would be secretary. Here, Brian would be president, Joe would be secretary, Joe would be vice president, Lisa would be secretary. So you notice just in those 2 lines, because order now matters, I have more possible ways of selecting these same 3 students. So when you're looking at it, you're going to have more permutations where order matters than you will combinations. Let's look at an example with the probability for combinations. 8 college students have applied for internships at a local law firm. 3 of them will be selected for interviews. Okay, so we have 8 total. So N is our 8. We're going to select 3. That needs to be an R, not a C. 3. 4 of the 8 are from Middle Georgia State College. What is the probability that all 3 of the interviewed students are from Middle Georgia State College? So the probability that 3 are from Middle Georgia State, there are 4 of them from Middle Georgia State. Now we need to see how many different ways can I select any 3 from these 8 students. Well, doing so, it's 8, choose 3. So I have 4, and then 8 factorial over 3 factorial, 8 minus 3 factorial. I have 4 on my numerator still. I have 8 factorial divided by 3 factorial times 5 factorial, which leaves me with a 4 on my numerator. The 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. 3 factorial is 3, 2, 1. 5 factorial is 5, 4, 3, 2, 1. You will notice that these simplify each other out. These actually simplify each other out as well, leaving me with 56 different ways of selecting 3 students from the 8 on the denominator, and I still have my 4 from Middle Georgia State College. 4 divided by 56, if I put that into decimal format, it's going to be 0.071. The probability all 3 students interviewed are from Middle Georgia State College is 0.071, 71 thousandths. Now you'll notice I put 4 on the numerator this time, and that's because there were 4 that were from Middle Georgia State. Remember, I want to look at the number of possible times it can occur just naturally, and that's 4, but then I have to divide it by the total different ways that we can look at it. And that's why I had to do the combination and simplify down into the 56 on my denominator. Continue working with combinations, permutations, the counting rule. Go back and watch the video regarding how to use the calculator with not just permutations, but also combinations. And then let me know if you have any questions.